This question is about some reactions of compounds that contain the acyl group. Write an equation for the reaction between 1,2-diaminoethane and an excess of ethanoic anhydride. So CH2, CH2. I'm writing this way up. You'll see why in a minute. NH2 and NH2 here. So that's 1,2-diaminoethane with excess ethanoic anhydride. Okay, so what we know with this is that we will cut along here. The carbon here will join to that nitrogen there, and then we'll lose one of the hydrogens off that nitrogen there. Now, the clue here is that there's an excess, and you've got a diamine. So this could, and does in fact, happen a second time. So CH3, COO, CO, CH3. So if I use a different colour here, so that will cut along there, and this one will join to that one over here, which means my product will be this. Oops, CO. CH3, let's just put the dots on and where they've joined together. So there's that carbon to that nitrogen there, and then there's that carbon to that nitrogen there. And of course, for each of the two where something has come off, I'm going to get two ethanoic acids. So there's that there, and I'm just going to tidy this up. So what I'm going to do is, now that we can see the working out here, I'm going to rub this one out, put that line out there, and then put a 2 in front of this to show that we get two of those. So if you only did one of the amides and you got an NH2 at the end, then you'd get 1 mark. If you've done the two amides with two ethanoic anhydrides, you would get 2 marks. Name of the mechanism, we'll come back to that in a minute. The thing that we've got here, and the example would love cyclic molecules, if you ignore this, you can kind of see what is going on here, okay? So the first step is done for us, so let's just concentrate on what's going on there. Obviously, I need a curly arrow from here to here. Remember that oxygen is D-. As the nitrogen forms a bond with the carbon, the weakest bond will break, which is the pi bonds, the second bond between the carbon and the oxygen's already pulling them towards itself. So let's put the oxygen up here. There's the lone pair and the minus charge, chlorine, and then my nitrogen is here like this, and then the rest of the molecule just hasn't changed. So CH2, 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 and then back up to there, positive charge on here. So 1 mark for this arrow, 1 mark for the correctly drawn intermediate, and then 1 mark for 3 arrows on here. It doesn't matter which of the nitrogen-hydrogen bonds you use. And then that gives me and then again, nothing else has changed here. Just gives me that plus HCl. And this is the nucleophilic addition-elimination mechanism. Okay, part E. So this is formed between benzene and an electrophile. So if I cut it here, that's going to be my electrophile. So this is the formation of the electrophile. So O, in fact, let's draw it out properly. So CH3, CH2, CH2, CO plus, and this, remember, has to come from the acyl chloride. CH3, CH2, CH2, CO. There's the Cl, and I use aluminium chloride, catalyst or halogen carrier, which gives me AlCl4 minus over here. The mechanism then for the reaction between that electrophile and benzene. So CO, CH2, CH2, CH3, positive charge on the carbon. Now the first arrow has to start at the ring or just within. So there's 1 mark for that arrow there. That's going to give me my intermediate. So it doesn't matter which carbon I put this on. So let's put my hydrogen there and this over here. And if you remember, delocalization cannot take part along there. So I go around the remaining 5 carbons and put a plus in the middle there. So 1 mark for the correctly drawn intermediate, and then 1 mark for the arrow going into there. And that gives us our product E over here. Okay. And then for E, compound E reacts with HCN to form 2 isomers. Name and outline the mechanism for the reaction of compound E with HCN. So benzene is here to really throw you. Don't let it throw you. With HCN, the only thing that it's going to react with is the carbonyl. So there's my CN minus. 1 mark for a curly arrow from there to there. 1 mark for a curly arrow from here to here. And then I've got my intermediate, so let's do the oxygen. There. CH2, CH2, CH3. Cyanide down here. And then benzene over here. And then this is with a H+. Remember, it's only the hydride that uses water. So curly arrow from there to there. And that's going to give me my hydroxynitrile. And again, this is going to be, this is my nucleophilic addition reaction. Okay, and if we look around here, you can see that we've got 4 different groups on it, which leads us into the next question. So let's just see where the marks are for this. So 1 mark for the name of the mechanism, 1 mark for each of the curly arrows here, 1 mark for the correctly drawn intermediate, 1 mark for the curly arrow to the H+, not the water. Remember, water's only for the hydride. And then separate samples, we use plain polarized light. That will get you 1 mark. And then the second mark is that each isomer rotate the plain polarized light by equal amounts in opposite directions.